In the last video, I have explained you the working of galvanometer. So in this video, I will explain you how can we use galvanometer as ammeter and voltmeter. See, galvanometer application is to detect the presence of current, but we need the same galvanometer to measure exact value of current and exact value of potential difference. Now for that we need to make some changes. I will explain you why changes are required. Okay, so we have a circuit here. Let's say current is passing through here. So first I am going to explain about galvanometer to ammeter. Okay, next galvanometer to voltmeter. So let's say current of 10 ampere is going through the circuit. We don't know the value, say for example. Now the moment I am connecting galvanometer, you know galvanometer, let's say this is galvanometer, right? So it is represented in this way. Now galvanometer has got inner core, right? Inner winding that is having certain resistance. Now let's say the resistance is, for example, 100 ohm. So what will happen? 10 ampere of current is passing through this. The moment we are connecting it with a galvanometer to measure the current, the problem here is now the value of current will get changed because the total value of the resistance has got changed. Previously, if the resistance is 50 ohm, now in addition to the 50 ohm, 100 ohm also will come. Now the whole current has to pass through a total circuit of a circuit having a total resistance of 150 ohm. You got the difference, right? Let's say we have a battery and it was sending current through 5 ohm. Let's say the value is 5 volt. So V is equal to IR, I is equal to V by R. 1 ampere current is passing. Now at the same time, when we are connecting one more resistance to the same potential difference, 5 volt, if it is having 5 ohm, so I have added this one. So the current has got changed. What is the value? I is equal to V by R, 5 by 10. So it is half. See, whatever we are measuring now is just the half of the original one. So this is not recommended here. So we have to make sure that the current is not altered, not changed when it is passing through galvanometer. So what we can do here, we have to anyway connect galvanometer in series, then only the same current will pass. But we have to make sure that the current will not change. What I will provide, I will provide a low resistive path here. Low resistive path. This is called as shunt resistance. Now current will reach here. It has got two paths. One is low resistive path and another one is the one which is having galvanometer in it. So current will obviously choose low resistive path. So out of 10 ampere, 9.5 ampere will pass through this. Only 0.5 ampere will pass through this. But the thing is, see, this 0.5 is proportional to the 10 ampere. What do I mean by that? Now when I am changing 10 to 20 ampere, I have multiplied it with 2. So this will also be multiplied 19 ampere and 1 ampere in this way. So always this current is proportional to this current. Okay. Now if that is the scenario, better we can calibrate this so that this will be adjusted. So our purpose is done here. See, thing is there are some current passing through this and this current is proportional to this. So we basically have to measure this. So let's say 10 ampere, instead of 10 ampere, only 0.5 ampere is measuring. We will calibrate it as when 0.5 ampere is measuring, it means by 10 ampere. How to get the value? You have to multiply the value with 20. So multiply with 20, you will get the value. Now if 20 ampere is going, only one coming in, only one is going through this, remaining everything is going through this. But one, when I multiply with 20, I will get the value here, 20. One more example. Now 10, when it will become 50. So we know I have multiplied it with 5. So multiply 0.5 with 5, that is 2.5. So what will be remaining? Out of 50, 47.5 will go through this. Now how to get the exact value? Multiply it with 20, that is 50. It is proportional. So in short, this is just an illustration. In short, what I am going to do is, I have a circuit. I have to connect galvanometer here. So galvanometer comes with its own resistance. But inside the galvanometer, I will connect a shunt resistance, a low resistive path here, so that whatever current comes here, majority will go through this and the current will not be changed. So this is the total galvanometer. So galvanometer has its resistance and a parallel resistor connected in, so a shunt resistor connected in parallel, that whose value of resistance is very low. So current will choose that path. This is conversion of galvanometer into ammeter. How to do that? We have galvanometer, it has its own resistance. We will add a shunt resistance having low resistance, and this now we will connect in the circuit. Okay, now in voltmeter the same thing. See, when voltmeter, I have to see, let's say this, I have to find the voltage difference in between these 2 points. So voltmeter will always be connected parallel. So let's say I have, if I am connecting galvanometer in this way, let's say galvanometer has a resistance of Rg, that is due to its own coil. Now if I am connecting this way, the problem here is, the moment we are connecting, there will be current passing through this. Now the total potential difference will get changed. Now how can we make sure that the current is not passing through this? I will add a very high amount of resistance in series. What is this one? The total thing is galvanometer here. Now with galvanometer I am adding one resistance in series, that is a bigger resistance, so that current will not go through this. Now I can get the exact potential difference in between these 2 points. Okay, so galvanometer, this is galvanometer. With that I am connecting a higher resistance. This is called as shunt resistance in series with the galvanometer. The whole thing is voltmeter now. Here in this case, this one is galvanometer with its own resistance, coil resistance. I am connecting a series. So this one is galvanometer. I am connecting a low resistance. A low resistance in series. So in parallel, I will get ammeter. So this one is ammeter, this one is galvanometer. Now you can get the equation for this. So here, see, this is shunt, right? So it will be the same current passing through this. So Ig will pass through even shunt and even through the same thing. So the net potential difference here is due to this one and this one. So it is nothing but Ig into the shunt resistance R plus Ig into Rg. So this is the potential difference across galvanometer. This is the potential difference across the shunt. That is the total potential difference. If you want an equation, you can write in this way. Here in this, current I comes and out of Ig will go through this and I minus Ig will go through this. Now you can equate voltage here. I minus Ig into R, I minus Ig into shunt resistance is equal to, it's the same potential difference with this, right? That is equal to Ig into Rg. So you can have a lot of equation here. So up to you can refer NCERT and get the equation. But this conversion is very important. Okay, thank you.